Are you wondering if the channel loss equation can be done by TX FFE only? The short answer is no. But in this video, I'm going to show the image of why not apply the TX FFE only in the equation. The table shows a few channel insertion losses at the next rate, which is specified in the multiple protocol or standard. As you can see, the loss range from 15 dB up to 30 dB. In your equation image, multiple SerDes must have the capability to equalize all different channel losses. Therefore, it's very straightforward to confirm all the specifications of the insertion losses and design for the highest insertion loss, something like the 30 dB or 36 dB loss at the next rate. In this video, we may only focus on the 30 dB case study instead of the 36 dB. As we discussed in the Why TX FFE video, the TX FFE can be implemented easy from the digital FIR with a few gates and flip-flops. In addition, the FIR can implement the precursor easily, so it can cancel the first precursor RSI. Sometimes people may call the FFE as the emphasis due to the DC swing being attenuated, which reduces the power efficiency due to the TX driver's output low impedance. In addition, the FFE cannot equalize too much loss above 30 dB to keep the power efficiency reasonably. Also, to deal with different channel frequency response precisely, more taps are required, but the power overhead will go up quickly. Usually, some standards like the PCIe only define 3 taps FFE, including pre-tap, main tap, and post-tap respectively, to achieve a reasonable power and area. Lastly, the I-scan or link quality is evaluated at the receiver. Therefore, the back channel is needed to send the control signal back and accomplish handshaking mechanism in the adjusting or optimizing the FFE tap coefficients. Here is a simplified time domain waveform of the FFE with the emphasis. If the channel loss is only 6 dB, then the de-emphasis level should be 6 dB or half in case 1. Then the equalized swing after the channel would be half of the maximum output swing of the TX driver. On the other hand, if the channel loss is up to 30 dB, then the de-emphasis level must be 30 dB in case 2. Then the equalized swing after the channel would be only 3% of the maximum output swing of the TX driver. For example, if the TX output maximum swing is 1 mole, then the maximum swing after channel will be roughly 30 mV only, which may not provide a big enough swing for the receiver. So there's either an input sensitivity issue at the receiver or a small signal-to-noise ratio to degrade the bit error rate. Here is the 30 dB loss case study with 3-tap FFE under an optimized coefficient. As you can see, both the precursor and first postcursor are quite big after the channel if there's no equation. But even a 3-tap FFE was applied, it's obvious both residual RSI of the precursor and post-first cursor are still too big. Then, the pulse response image shows that the simple 3-tap FFE cannot equalize a 30 dB loss. Let's extend a single shot or single pulse response case to a PRBS7 bitstream case. As you can see, the PRBS7 I diagram will confirm that the pulse response result that the I is still close after applying 3-tap FFE in the time domain. The PRBS7 I image in the time domain shows the TX FFE only cannot equalize the 30 dB loss at the next rate. In the frequency domain image, the 3-tap FFE's 10 dB high pass boost cannot equalize the channel's 30 dB loss well, which results in only 1 GHz 3 dB bandwidth in the overall cascaded frequency bands. So please be advised that more taps are required to equalize the 30 dB, but we don't prefer this approach. Instead, we are seeking more bits of help from the continuous time linear equalizer. Otherwise, the equalized swing after the channel would be only 3% of the maximum output swing of the TX driver, and the signal-to-noise ratio at the receiver front end would be very little. Here is the summarized image you may have for why not only TX FFE in the equation. If the TX FFE only must equalize a loss up to 30 dB, then more taps would be required to achieve a necessary 30 dB boost level. Then that will lead to more power and area. In addition, the equalized swing after the 30 dB loss would be only 30 mV after a 1 volt TX maximum output swing. If the SerDes power or area budget is limited, then only 3-tap TX FFE is feasible, and that's even specified in most wireline standards. Then there's no way for a 3-tap TX FFE only to equalize a 30 dB loss, which was demonstrated in the case studies. So, in a realistic system budget, the TX FFE may only equalize up to 60 dB loss and get help from other equalizers for a total 30 dB loss target. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback, and please share your comments down below. Lastly, please share the video link with people who may benefit from it.